Hey calculus students, we are continuing our study of chapter 2.6 and several of you asked for page 119, question number 9. So the problem asks you to find an equation of the tangent line to the curve at the given point. So our function is x minus 1 over x minus 2. Our given point is 3, 2. So you might be wondering which of our definitions we are going to use. Well, I will always choose to use that definition number 2 or equation number 2, the limit as h approaches 0 of f of a plus h minus f of a all over h. The other definition might seem simpler, but it does not always result in a limit you can evaluate algebraically, whereas this definition we will always be able to evaluate algebraically. Okay, so first thing I'm going to do is substitute a with what a is equal to, which would be 3. So my limit as h approaches 0 of f of 3 plus h minus f of 3 all over h. Now we are being asked to substitute f of 3 plus h, or evaluate f of 3 plus h, which means substitute 3 plus h into my function for x. So my front end here is going to be 3 plus h minus 1 over 3 plus h minus 2. My back end is the f of 3. So normally I would substitute 3 in, but in this case they gave us what f of 3 is equivalent to, which is 2. And that is all over h. And now we want to evaluate this limit. We always try direct substitution first, but if I substitute a 0 in for h, I'm looking at an undefined function. So let's see if we can simplify this complex fraction a little bit. So we have the limit as h approaches 0. And on top, we've got 3 plus h minus 1, so that is 2 plus h over 3 minus 2 plus h, which is 1 plus h, minus 2 all over h. So you have two choices at this point of how you simplify this expression. You can combine the two expressions in the numerator if you want, and then divide your top fraction by the bottom fraction by multiplying by the reciprocal. I choose instead to multiply the numerator and the denominator by the least common denominator of all my little fractions. And that denominator is a little fraction of h over 1. So what am I going to multiply by? My common denominator would be 1 plus h. And as long as I multiply top and bottom by the same expression, those are equivalent to 1. And that's a legal move in math, so we're allowed to do it. So we're left with the limit as h approaches 0. And then we're going to distribute here. So when I distribute 1 plus h, the 1 plus h here is going to cancel with the 1 plus h over here. So that's really going to be gone, and I'm just left with 2 plus h on top. And when I distribute here, I'm going to be left with minus 2 times 1 plus h. On the bottom, I'm not going to distribute that at all. I like that it's in a nice factored form already for me. And we're going to clean this up a little bit. So 2 plus h minus 2 minus 2h all over h plus h squared. Oh, I'm sorry. We don't want to distribute that. Silly me. Sometimes that just becomes... Oh, I just learned something new about my pen. Sometimes it just becomes a habit to distribute on the bottom, but I would have to turn right around and factor it. So let's get rid of that. Okay, so we are going to keep that as h times 1 plus h. So 2 minus 2, these are going to cancel right here. What am I left with? H minus 2h is negative h over h times 1 plus h. And my h's here are going to cancel. So what I'm left with is the limit as h approaches 0 of negative 1 over 1 plus h. And now I'm going to substitute my 0 in. So negative 1 over 1 plus 0, which is negative 1. Remember what we're finding. We are finding the slope of the tangent line. So I now know my slope. Remember our point from earlier was 3, 2. Okay, so we're going to come back down here. What we're really being asked to find is the equation of the tangent line. So we're going to have y minus 2 equals -1 times x minus 3. I am okay with this format right here. You get full credit for that on my test, but you know your book likes to distribute. So I'm going to add 2, so I have -x plus 5 for my final answer here. Okay, thank you so much for listening. Again, if you have any questions, shoot me an email.